Welcome back to another training video using the UK Electrical Simulator. In this video, we're going to look at how to wire an electric shower, compare a couple of common shower ratings, change the cable size and cable length, and then check the voltage drop to help confirm whether the circuit design is suitable. We'll also make use of the shower ratings guide in the resources section, which gives a useful rule of thumb guide for current, cable size, and protective device selection. An electric shower should be installed on its own dedicated radial circuit. For smaller rated showers, 6mm squared 2-core and CPC will be more than suitable, but cable choice must always consider the full design, including installation method, thermal insulation, grouping, cable length and voltage drop. That last point is especially important. The longer the cable run, the greater the voltage drop, and that may mean increasing the cable size even if the current carrying capacity looks acceptable. The rating of the RCBO also depends on the shower load and the circuit design. Smaller showers may be suitable on a 32 amp device, while larger showers may need a 40, 45, or even a 50 amp protective device. So let's bring that into the simulator. On the workspace, we have a C1 bus, protected by a 32 amp RCBO, a double pole pull cord isolator, and a 7 kilowatt electric shower. The actual pull cord of the isolator switch is allowed in zones 1 and 2, whereas the switch itself should be beyond zone 2, for example above 2.25 meters, while the pull cord may drop into the zone. With the circuit energized, we can see from the clamp meter that the shower is drawing 30.43 amps, which is exactly what we would expect from a 7 kilowatt shower on a 230 volt supply. If we now run the voltage drop test, the meter shows a drop of 3.94 volts, which is 1.71% of the overall voltage. That is below the usual 5% limit for a power circuit, so the circuit passes on the voltage drop. If we open the detailed information panel, we can also see that the simulator is recommending 6mm squared cable, which matches the guidance shown in the shower ratings table for a 7 kilowatt shower. That table is there as a quick training guide, but it is still important to remember that it is only a guide. The final cable size and protective device selection must always be confirmed by proper design. What this example clearly shows is that the shower load, the protective device, the cable size and the cable length all work together. If the shower rating increases, the current increases. If the cable run gets longer, the voltage drop increases. And if the cable rating is too small, the voltage drop may become unacceptable, even if the shower still appears to work. So, in practice, we can use the simulator to try different combinations of shower rating, RCBO size, cable size, and cable length, then compare the results against the shower ratings table and the voltage drop meter to see whether the circuit design is suitable. Let's make a few changes to see that in action. First, isolate C1, then double-click on the shower and change it to an 8.5 kilowatt model. The shower ratings table shows that this would typically require a 40 amp protective device, so double-click on the C1 RCBO and change it to 40 amps. Now energize C1 and run the voltage drop test again. This time we see a voltage drop of 4.78 volts and a current draw of 36.96 amps. At first glance that may seem acceptable. However, the shower ratings guide for an 8.5 kilowatt shower suggests using 10mm squared cable. However, based only on the current and voltage drop readings, you might be tempted to think that 6mm squared cable is still acceptable. But in a real installation, you also need to take account of factors such as the installation method, thermal insulation, grouping, and other design considerations. Now let's keep the cable size the same, but increase the cable length to 50 meters. First, isolate the C1 circuit and press the W button on the bus and change the wire lengths from 20 meters to 50 meters. Then energize the circuit and run the voltage drop test again. This time we see a reading of 11.61 volts, and the additional information now shows a fail warning because the voltage drop is above the 5% limit. The simulator also recommends increasing the cable size to 10mm squared, as recommended in the shower rating table. So let's quickly make that cable size change and run the test again. This time the circuit passes. As you can see, there is quite a lot to consider when designing a shower circuit. But hopefully this simulator helps make those decisions clearer and gives you a practical way to compare different cable sizes, protective devices, and cable lengths before settling on a suitable design. I hope you've enjoyed this video looking at electric shower circuits and how to choose a more appropriate cable size and protective device. Please like, subscribe, and leave a comment below.